Hey guys, welcome. Today we are going to make a level select screen complete with locking and unlocking and a player that moves around on the screen as well. We're going to make it dynamic so there's no placing anything by hand. It's all done with code and it's modular so you can add or remove levels very easily. Ready? Let's go. So first we'll get our canvas set up, and if you want any glow or post-processing to affect your UI, then set it to screen space camera, but if you don't need that, then screen space overlay is fine. We're going to add a game object called level select, and in there another blank called layout, as well as a text for the name of the area and some text for the name of the currently selected level. For now, we're just going to add a grid layout to our layout object, and you can size it however you want. You can add padding and spacing if you want, and the cell size here controls the size of any objects that we add as children of this game object, just in case you didn't know. Now in there, we're going to add an image, which is going to be our actual level. I'm going to keep the visuals really simple to keep this tutorial as unbloated as possible, but whatever sprite you want to add here for your levels, this is where you're going to do that. I'm just going to use a circle though. Now add a button component to it, and we'll get rid of the transitions because we'll handle that ourselves, and the on-click event will be subscribed to with code as well, so don't worry about that here. Now let's add some text to it and place it slightly above, and this will just display the number or ID of the level so that we know it's spawning right. Okay, so we're going to need a few scripts. We're going to create a level data, which will hold the data for each level, and create a level select manager, which is going to be responsible for reading the data, spawning in the UI, and it'll handle the unlocking as well. And also create a level button script, which is going to handle the color of our level UI as well as assigning the on-click event here. Let's add the level button script to our level button here. And now let's turn this game object into a prefab. Now, before we set up the level data script, there's a link to a forum post in the description of this video. Go there and copy the code from glitchers there and set that up as a script in this project. I don't like using strings for scene references. That gets messy really quickly. And this script will actually allow you to drag scenes as fields into the inspector and reference them that way. So even if you rename them or reorder them or anything like that, it's not going to matter. It'll automatically update. So once you've grabbed that code and you've got the script in your project, once you've done that, open up level data. This is all pretty self-explanatory, I think. Just note that the is unlocked by default here. It's really just meant for the first level in each area. When we actually unlock levels, we're not going to touch this because scriptable object data persists between scenes and it can get confusing and messy, so we're not going to do that. We'll handle that separately. Okay, let's do the level button. So we're just grabbing a few references to what we need at the top, and then getting what we need from awake. But what's really important are these three methods. The setup we'll call right when we spawn the button. It'll set our text for us by reading it from the level data, and we'll only make the button interactable if the level is unlocked. And interactable means you can still navigate to the button, but you can't click it, or if you click it, it doesn't do anything. And if it is unlocked, we'll add our button listener. And so that we can visually see what we're doing a little bit better, I'll make unlocked levels white and locked levels gray. The unlock function will actually call when we dynamically want to unlock a level, which would probably be after we beat the one right before it. So when that happens, we'll set the interactable back to true. We'll add the button listener, and again, we'll change the color since the setup is only done when the button is first spawned in. And then what the actual listener is calling, this is where we'll load in our scene. And before we forget, let's open up the level button prefab and assign the text in there. And before we do our level select manager, we need one more simple script called area data. And this, just like level select, is another scriptable object with just a name and a list of the levels for this particular area. Now let's deal with the level select manager, which is going to be the bulk of the work for this project. And at the top, let's just set up the bulk of what we're going to need right now. These lists and dictionaries and what they're for will make more sense a little bit later when we actually use them, but for right now, just know that we will eventually need them. But hopefully besides that, all of this makes reasonable sense. Where we spawn, what we spawn, text that we want to update, and our area which holds all of our level data. This hash set is basically like a list of strings, except a hash set won't allow duplicate entries. And we'll go ahead and grab our camera reference in awake. So in start, what we're going to do is assign the area text, load our unlocked levels, and then create our actual level buttons. So assigning the text is pretty straightforward. We can just set the text based on our current area's area name that we set. For loading our unlocked levels, if we selected the is unlocked by default, then we'll add that level to our unlocked levels hash set. So now in our create level buttons method, we'll iterate through all of the levels. And for each one, we're going to spawn in our actual level button prefab and add that to our list of button game objects. We're also going to need the rect transform later when we change the actual navigation options. So grab that here. And this is optional, but I like to change the name of the game object that we spawn in to match our level name or level ID, whatever you want. And we also had a level button object in our level data scriptable object, so we can assign that here when we spawn it in because we'll also need that a little bit later. And finally, let's call the setup method from our level button. So we'll need to get that component as well, pass in the current level data, and whether it's unlocked will depend on whether our hash set contains this level ID or not. All right, so let's test to make sure this is working like we expect. So first we need to create some level asset files and populate them. I don't really have levels in this test project, but you can see if I create a new scene, you can plug that in right here. And don't forget to set your first level to is unlocked by default. After that, we need an area asset file called, well, whatever, whatever you want. And we can plug in all our levels in there. And now we add the level select manager to our level select object. The level parent will be the layout object, and we already made a prefab for this. We can plug in our texts and our current area. And let's hit play. Okay, so I mean, there's nothing too impressive yet. The biggest issue right now is that we can't really do anything with these yet. Now, if you are familiar with the iSelect and IDSelect interfaces for the UI using the event system, or you already have your own system using that, go ahead and implement it here. But I'm going to put up a card for a video here. The link will also be in the description. My recommendation is to follow that and then come back to this point in this video with the menu event system handler script that you will create in that video. Trust me, it makes everything with UI in your game easier to deal with. It's really great. I use it in every single game and project that I create that uses any kind of UI at all. Now, once you have that script, I'm going to create a second version of it called Dynamic Event System Handler. I'm just going to paste everything in there and just change a small handful of things so that this actually works with dynamic things that are spawned in. We don't need this, or this, or this either. Change this to index 0 of selectables. Get rid of these. And make sure all these methods are virtual so that we can override them because we're going to need to do that. And finally, since we're dealing with dynamic selectables that are being spawned in at runtime, we need a couple of helper methods. So we'll make a method that lets us add selectables. An initializer method that will add our event listeners. As well as setting our first selected as well. Now, UI, when you deal with layout groups, is kind of annoying because you always need to give them one frame to reposition themselves based on what the layout group does. So we'll call this coroutine, which sets our selected game object in our event system after one frame. Oh, and also get rid of these here. Okay, now we're going to create a new script called level select event system handler and make it inherit from our dynamic event system handler because we'll need to change a few of our methods in there. We don't need to do that just yet though. So for now, just add that script to our layout object and plug in your navigator reference, which is whatever action map that you have activated when you use your UI. If you want to add a sound effect in there whenever a level is selected, then you can add it here. And now if we go back to our level select manager and we get a reference to that script, and in Awake, we'll find it in its children. And after setting up the level button, we'll get our selectable component and call our add selectable that we just set up. Then finally, after the loop is done, let's just make sure that our level parent is active. We'll call our initialize method and set our first selected from the level select event system handler. Once all of that is done, and just for now to test, I'm going to make sure that all levels are unlocked, and I'm going to hit play. And you can see that our level scales up slightly when it's selected, and we can navigate around, and you can do it with the keyboard or the gamepad. It's just going to work. But what I'd like to do right now is that when we select a level, I want to also make it turn red. So let's open up our level select event system handler script. So we'll need a reference to our image, our level button, and our level select manager. The manager is the only one that we're going to grab from Awake though. Also, while we're here, I actually don't want to be able to select the levels with my mouse just by hovering over them. So I'm going to override our on pointer enter and on pointer exit and just leave them blank so that they do nothing. But in the on select and on deselect methods, we'll call the base methods in there. And in select, we'll also grab our image and level button components. And if the level button is not null, we'll set the level text. And if the image is not null, then we'll set the color. And when we deselect the button, then we'll set the text to blank and set the color to its return color. Okay, and let's make sure that that is working as well. Okay, that's looking pretty good. Next, let's get these levels connected together. And to do that, we can use line renderers. So we're going to create a new game object and add a line renderer component. I'm going to make the width nice and small and make sure that we do use world space here. We can turn off lighting, and I'm going to change the order and layer to something like -10 so that it renders behind the level sprites and text. Now we're also going to need a new script called line renderer connector, and we'll add that to our level connector. And actually now we can turn this into a prefab and then delete it, but let's open up the line renderer connector script. So this script is going to be in charge of setting the positions of the line. And to do that, we'll need references to our start and end rect transforms and the line renderer itself and the camera. So we can grab our line and camera in Awake, and then we'll create our update line position method. But before we can populate this, we need a get world position method, which is going to take in a rect transform. Our grid layout handled the positioning of the level images for us, but it's not going to do that for our line renderer because this is not a UI graphic. It's basically more like a sprite. So the layout group is not going to do anything with these. So we need to calculate the world position ourselves. So first we need to grab the screen position of our rect transform and then turn that back into a world point by calling camera.screen-to-world-point. Now that we can translate our position properly, we can grab our start and end point for the line renderer, set our position count to 2 just in case it's not already, and then set our points like that. And now in our level select manager, we need a reference to our line renderer prefab. And we want to spawn those in now, but just keep in mind that we're actually going to do it backwards so that it looks right visually. So at level 2, we're going to spawn a line that connects level 1 and 2. And at level 3, we're going to spawn a line that connects 2 and 3, etc., etc. So if I is greater than 0, we'll instantiate a line. We're also going to set its sibling index to 0, which is just going to move it to be the first child of the parent, since for UI rendering, the order matters for which is displayed on top of what. And we need to grab our line connector script. And I forgot that this should be a line renderer, not a game object. So let's do that. And then set our start rect and end rect transforms. Now we need to set up a delayed line setup coroutine because remember we have to wait 1 frame to update the positions because of the layout group, because it takes the first frame to do that itself. So we'll wait 1 frame and then we'll call our update line position method. And we'll call that coroutine here. So let's test again. We can add our line prefab here. Don't forget to assign a material to your lines or it's not going to show up properly. All right, so it is working. Next, I don't love the layout of this so much, so let's change that next. And we're going to create a new script called zigzag layout group. And I'm not going to run through this because it's outside the scope of this tutorial. And I also can't zoom it out all the way or it's way too small for you to see. So here is the top portion of the script and here's the bottom portion. Okay, now once you've copied this, we're going to go back to our layout object and get rid of the grid layout group and replace it with the zigzag layout group. I'm going to plug in the same padding and spacing and cell size. And now we can hit play and you can see that that's looking much better than before. And if you want to inverse the order, you can just untick this box here. And now you can see that it runs from right to left. All right, so one of the last challenges that we need to tackle is how to deal with navigation properly, because right now we can navigate to any of these levels, whether they're unlocked or not. Plus we can skip a whole bunch. Like if I press down here, I'll go from 1-1 to 1-8, which I really don't want. I want to force the player to follow along this linear path. And that's where this list and this dictionary are finally going to come into play. So first we'll create a coroutine called add location after delay. Well, again, we'll wait 1 frame and then we'll do that same conversion again, going from screen point and back to world point to get the world position of our level button. And then add that to our dictionary with the button game object as the key and its position as the value. We keep a dictionary of these because we need to know the location of each buttons in order to properly set up our navigation. Okay, and we'll call this coroutine right here. And we're going to create one more coroutine called setup button navigation. And again, we have to wait 1 frame first to let the layout group do its thing. So now we'll iterate through all of our buttons. We'll grab our current button, and from that, we can then grab our current position since we just added that to the dictionary, as well as the current selectable, and create a new navigation struct, setting it to explicit mode. So first we'll check on the previous level if one exists, and then the next level if one exists. So for the previous check, we check if I is greater than 0 and make sure that the level is unlocked. And if I is less than the count -1 and it's also unlocked, then we're checking the next button location. So in the previous, let's actually grab our previous button as well as its position, and then calculate the direction from one to the other. We're literally going to set the navigation based on the direction, okay? And in order to do that, we need 4 checks, 1 for each cardinal direction, using vector3 ... And if you're not familiar with vector3 ... or the dot product, the gist is that it returns a number between -1 and 1. If it returns 1, the directions are exactly the same. If it returns 0, they're perpendicular, meaning 90 degrees apart. And if it's -1, they are literally in the opposite direction, meaning 180 degrees apart. So that's the gist. So knowing that, we can say if the dot product of our direction to previous compared to vector3 .right, if that's greater than some threshold, and we're just going to say 0.7 since that's pretty close to 1, but not exactly 1, then we'll set our nav.selection on right to be our previous button selectable. And we're just going to do that again, but for left, and navigation on left, and up and select on up, and down and select on down. And basically, we're going to do the same thing with the next buttons as well. So we're going to grab the next button as well as its position, and we'll calculate the direction from one to the other there as well. And very, very, very similar here as well. We're going to plug in our dot product and check for the right, left, up, and down. Okay, and then finally, we'll actually set our current selectable.navigation back to the nav that we created. And we can call this after the loop in create level buttons since it loops through everything all by itself. So let's play to make sure that this is working. And when we hit play, you can actually literally check to make sure that they're right here in the navigation. You can see for level 1, we can only go right. For level 2, we can go left or right. Same for level 3. And then the 4th, we can go down or left. So that's great. That looks like it's working. Now I'm actually going to put these back to default now. So to actually get unlocking working, let's create a helper method and a test method as well to make sure that it's working. So the helper method that we'll call whenever we want to unlock a level is really simple. We're just going to add the level ID to our hash set. We'll call the unlock method from level button, and then we'll call setup button navigation again, since that needs to be recalculated. And for our test, we're just going to grab the second button, so level 2, grab its string, and call the unlock level method. And we'll add a context menu attribute above it so that it's easy to call. So now when we press play, only level 1 is open. We can't navigate anywhere, but if we right click on our level select manager and we run the test method, you can see level 2 unlocks, and now we can navigate there and back and forth. So finally, let's get a player that spawns in and can move around on the levels. I've gone ahead and I've created a world space canvas in my scene here. And the only thing you need to know is just to make sure that it has a higher order in layer than our other canvas, because we need our player to spawn on top of the other one. And I have a simple player character here that I've turned into a prefab. And by the way, spawning your player into a world space canvas, he can be a sprite, he can have animations, all that good stuff. You can have particles, everything. It does not have to be an image. That is the beauty of this setup. Now back in the level select manager, let's set up the variables that we'll need up here. So we're going to start by spawning him in. So we'll set up that method and we're going to pass in the screen space UI object and the world space UI object. We're going to need those to properly set his position in the world as well. So since my player is facing right by default, I will set this to true. Then I'll spawn him in, and now we'll find the world position of the button that we want to send him to, but also taking into account an offset position that we set in case you don't want him directly in the center of the button. And then we'll move him to that position. Now, I would like to be able to turn him based on the direction that he's moving. So let's set up a method to turn him left or right. If he's facing right, but his target position is more to the left than our current position, then we'll turn him around. And if he's facing left, but his target position is to his right, then we'll turn him back around again. So now when we spawn him in, I want to make sure that he faces the direction of the next level, wherever that may be on the map. So we'll calculate the position of that button and then turn the player left or right accordingly. And again, we need to run this one frame late because of the layout changes. So let's call this method in a coroutine. And we'll call that coroutine if we are on the first index, meaning the very first level of the map. Okay, now the final method to create in this script is the move player to button method, because when we select a level, we actually want to move him there. So we'll calculate the world position again, check if he needs to turn left or right. And I just realized I have an error up here. This should be a 1, not an I, because we're looking at the second level and orienting the player towards it. Now, back down here, we'll move him to his position using Dotween to do it smoothly over time. Now, where we'll call that method is in our level select event system handler. And I've found the direction the player faces gets messed up when he first spawns in because we spawn him, we do a left or right check, but then this method runs automatically because we set our first selected afterward. So let's just set up a bool just to skip the initial check here in this script. And once it's complete, we'll move the player to the button, then set it to true. So this will run every single time except for the very first time that this is initialized, which is exactly what we want. And now if we plug in our player and world space canvas and enter a little offset if we want, you can see that we have our player moving around, but that doesn't look right. And that is because I accidentally put screen to viewport instead of screen to world point here. Let's try that again. All right, there we go. As a special thank you to all of my patrons, you guys have access to a special version of this project that has a whole bunch of shaders and the ability to create secret or optional levels that shoot off the main path. So if you want access to that project and you want to help support the channel at the same time, go check it out on Patreon. Thank you so much for watching, guys. I hope you enjoyed.